Good morning, everybody. Here we go. So what I want to do in this video is focus on the idea of going from a picture to an equation. So example, state an equation, right? State an equation or provide an equation for each function. So let's do a handful of examples where I draw a graph of a function, and then you have to give us an equation that goes with that picture, with that function. So state an equation for each function. There are many different answers. Just give me any one answer. So let's try all of these problems together. So let's see. So for example A, let's suppose you go to the X and Y axis. And let's say that your graph happens to be a parabola. And let's suppose that it looks like this here. Okay? And then what they give you a point there, and they give you a point here. And let's just make up these coordinates. Let's say this is like 3, 1. And let's say this is like 6, 7. So let's do a handful of problems like this here, where you have a graph and you have a couple of points. And sprinkled throughout this video, I will have random Lee commercials. Let's see. So you see this on your homework, on your notes, on your test, whatever. How am I supposed to, what a formula do I use for this? Well, look, this is a parabola. And because it's a parabola, we can use a format or a formula or a template that looks like this. Y equals a x minus h squared plus k. This is one possible way to write the equation of a parabola. There are several ways. This is just one of them. And this is a nice way because the name of this formula, this is what we call vertex form. And vertex form really comes in handy when you're given the vertex, which here is going to be 3, 1. So if you're given the vertex, then you want to label the coordinates of the vertex as h and k. And that's actually the first thing you want to do. You want to take your h, which is 3, and plug it in for h. Take the y coordinate of the vertex and plug it in for k. Let's actually do that first. So let's take the 3, 1 and plug them in for h and k. So our equation would then look like y equals a x minus 3 squared plus 1. The only thing left to do is discover the value of a. Now, to do that, take the random point. You see this point there? That is a random point. So take that random point, take its coordinates, and plug in the coordinates for x and y. Let's do that right now. So 7 goes in for y. And then the 6 goes in for x. Temporarily, right? Temporarily, x and y change to these numbers, temporarily. Now, solve this equation for a. Let's see. So how about we take the 1 away from the 7 on the other side, and that'll be a 6. And then let's go parentheses. 6 minus 3 is 3 squared is 9. Now to solve for a, we can divide both sides by 9. These are gone. And 6/9 can reduce to 2/3. So that's the value of a, which we'll plug in right there where the green arrow is pointing at. So we have 2/3. 2/3. 2/3 goes in for a. So final answer, y equals 2/3 x minus 3 squared plus 1. Again, if you see this on your solo quiz, there are a lot of different answers you can give me, but this is one really common answer. If you graph this on Desmos, it should look like this here. Maybe not exactly because I didn't draw this to scale, but it should have these attributes. All right, cool. How about we take a commercial break? This is my associates. This is my bachelor's in pure mathematics. This is my master's in pure mathematics. Notice there's plenty of space there for a PhD, which I'll get someday, but not today and not tomorrow. I'm still recovering
from the journey that was the master's degree.
Okay, welcome back. So now let's try example B. Or you know what? Before we go to example B, a really quick comment. Pencils down, just watch. What if you had a parabola that opened down? Well, you would use the same model, this one here. And first you would take the vertex, H and K, and plug it in for H and K. Always plug in the vertex first. And then the other random point, you would plug in those coordinates in for X and Y to discover A. So at the end of the day, there should be a Y and there should be an X. The H and K get turned into whatever the vertex is. And the random point is used to find the value of A. Okay? All right, how about example B? Let's go with something that looks like this here. How about you put a dot, let's say right there. And let's say you go like this, watch. Let's say you go like that. And then put a random point here. And let me give you some make-believe coordinates. How about we have like, let's go with -5, 7. And let's say over here, this is like 8, -2. Again, I don't know if this is to scale. At the end of the day, this could look way different on Desmos, but just trust the random sketch and then just use the correct equation. Not necessarily to scale. So for a situation like this, you identify what kind of function this is. And based on what I see, this is a square root function. So for square roots, we can use this model here. And I should make another comment saying that if the square root points to the right, which this does, if it points to the right, and this one, because look, the arrow is pointing to the right. If it points to the right, you want to use this model that we're about to use. Let's see. So first things first, you want to take this point there. That's your H and K, and plug in those numbers in for H and K. Always plug in HK first. So if we do that, this would go Y equals A square root X minus -5 plus 7, right? The H is -5. So there's a double negative, and we know those clash to give us a positive. So this is like X plus 5 plus 7. And now all that's left is to find the value of A. To do that, take your random point and plug in the random point in for X and Y. Always for X and Y, the random. The special point goes in for HK, right? But the random goes in for X and Y. So let's see. So -2 goes in for Y and 8 goes in for X. So we have -2 equals A square root 8 plus 5 plus 7 on the outside. And then we can subtract 7 from -2, and that'll be -9. And this is A, and then square root 13, because 8 plus 5. Now, the square root 13, just leave it like that. You don't have to go decimal. No, just leave it square root 13 and divide it below the -9. And boom, that reveals to us the value of A. So take your A value and plug it back into where it belongs, right? You want to take your A and plug it back. So take that and plug it back in for A. So A was -9 over square root 13. Let me erase some of this. -9 over square root 13. So final answer, -9 over square root 13. And then times the square root of X plus 5 plus 7 off to the back. Boom. Final answer. And then now let's do example C right after this short commercial break.
So check out my Back to the Future shoes. Check out my Power Rangers Dragon Dagger. How about the Power Morpher? Check out my custom-made Cal Poly Pomona graduation shoes that I made myself. Some more custom shoes. Check out the Dragon Zord from 1993 in like perfect condition. The Megazord. How about the GOAT himself? And how about Kobe? And then let's just zoom over here. A little poster of Michael Jordan, the 88 dunk contest. You see those shoes right there? Yeah, those are like my favorite shoes of all time, called the White Cement 3s from 1988. The most beautiful shoes to ever be created. More Kobe, the game ball, and of course, the Mamba mentality.
Now, before we move on to example C, a quick comment here. So this square root function, it pointed, boom, it pointed down. What if you had a square root that pointed up to the right? You see, look, this one opens up, but it's still to the right. The one we did pointed down to the right. So if it points to the right, period, you want to use the model that we used, whether it opens up or whether it opens down. You know, if it opens up, you can expect A to be positive. If it opens down like ours, you can expect A to be negative, which it was when we did example B. Now, really quickly, what if you had a situation where the graph was a square root, but it pointed left, whether it's up or whether it's down? In that situation, when it points to the left, you want to use this model. Y equals A square root H minus X plus K. See, it's kind of backwards from example B. And in that case, this point here, special point, that would still go in for H and K. It would go in there for H and K. And some randomly given point would go in for X and Y. See that? So it's just a different template for the ones that point to the left. All right, so how about one last example here for today? How about example C? So go to your axes, like that there. And let's say that this time you have a cubic. A cubic. So a cubic function could look like this. Put a dot right there. And then let's do like a zigzag motion. Let's do a zigzag like this. Watch. Let's go like that. And let's sort of twist and turn. And let's go up like that. And this is our special point there. And let's say the coordinates are -3, -2. And then you have a random point right there. And let's suppose those coordinates are like 1, 4. So for a cubic function like this one, here is the template you want to use. Y equals A, X minus H cubed plus K. You see, it kind of looks like the parabolas model, but instead of a power 2, boom, it's a power of 3. And follow the same procedure. Take your special point and plug it in for H and K. So let's see. So Y equals A, X minus -3 cubed minus 2. And H and K have been plugged in. Let's clean this up. Y equals A, X plus 3 cubed minus 2. Double negative became positive. That's all that happened. And then your randomly given point goes in for X and Y. So we have 4 equals A, 1 plus 3 cubed minus 2. Let's see. So X and Y. Now why don't you add 2 to the 4 on the left, and that'll bump it up to a 6, right? That'll bump this up to a 6. And then in here, you should have 64 because you go 1 plus 3, 4, 4 to the power 3, 64. And then divide 64, reduce that fraction if you would like, and boom, that is the value of A, which goes in right there for the value of A. So 330 seconds, 330 seconds. So we have 330 seconds. So Y equals 330 seconds. Now don't leave just yet because I have one quick comment to make. Done, final answer. So what if the given picture, like the one, that was example C, but what if you had a situation where it zigzagged in the other direction? Watch, in red. Let me just do this in red. You pencils down, just watch. What if it looked like that? You see, so that's still a cubic. And in that case, you'd use the same model, but in that instance, the one that's red, you can expect A to be a number that's negative, okay? Now, one last thing here. What if instead of like that, what if instead of zigzag up and down, what if you had a picture that zigzagged, but like sideways? Look, look, look. See? This is kind of sideways, right? You see that one in red? Or how about this one here in green? Look, that's kind of sideways. The green one and the red one, those are like sideways. So those are not cubic. That's what we call cube root. And that has a different equation. Let me tell you the formula for that one. For this red one or for the green one, however it looks, it would be y equals a x minus h to the power of 1/3, right? Example C was what we call cubic, and it's a power 3. This quick comment that I'm making now is called a cube root, and it's more sideways. You see how the arrows go more sideways? The cubic, the arrows go more dramatically up and down. The cube root, the arrows are more sideways, where this green version would have a positive value of a, and this red one would have a negative value for a. So Monday morning, you can expect a quick review of this, and then the solo quiz, and then the returning of the team quiz, and then new notes on trigonometry. So if you have any questions, let me know. Not have a great weekend. See you guys on Monday.